Hi everyone, Niklas here from the Softstarter team. Today we will learn how to select the right Softstarter for your motor and application. We are going to use our selection tool ProSoft and look at all the different steps and highlight what information is critical for a good selection. So if you would like to follow with your own computer, then you can download the software from the link in the description. Let us start and opening the program. Upon first opening ProSoft software, the home screen shown here appears. Let us first get familiar with the two menus, File and Help. The File menu includes quick links to create new projects, open previous saved project, saved current project, or save the current project with a new file name or location. It also has a menu choice to change the language to one of the 12 available international languages supported, that you can see on the screen now. You can also change the unit of measurement between imperial or NEMA as used in US and SI or metrics, which is used everywhere else in the world, that you can see on the screen here. And then you have Exit under the File tab. The Help menu has two links, the Content and About ABB ProSoft. The Content link opens a comprehensive online help system which explains virtually all feature and function available in ProSoft. The About link opens a dialog box which lists the version of copyrights data in use, as well as the motor and software database including in the software. At this time, the latest ProSoft version is 6.3.11. That is the current version. Users should check the ABB website frequently to download the most current free version of ProSoft. The Input tab, the default screen that opens, has three main sections: the general data, motor data, and load data. All three sections must be completed in order to move on to the next page or tab. Get this data from the customer or from the motor manufacturer. To properly size a Softstarter, it's vital to know environmental variables such as maximum ambient temperature and elevation. These are important as they influence the ability of the system to dispatch heat and also to prevent short circuit between the input phases, which can occur at a high altitude due to air that is more dense. It is also of utmost importance to know details regarding the motor and the load, as this will greatly impact the amps, the current capacity, and the torque rotational force required to do the work. These all have a significant impact on selecting the correct Softstarter. We will look at these buttons in the motor data and load data section individually. The next step is the motor data section, where we select the correct motor. The easiest way is to push the Select Motor button. This opens a database of various motors from ABB and Balder, which with a variety of power range, types, speeds, current limits, and torque limits. Both NEMA and ISE motors are listed. Choose the motor that matches the customer application, then click OK. For change the default of a motor that is not listed in the ABB Balder database, click on the Motor Data Edit button. This page allows for manually enter of motor nameplate data from any motor that is not listed in the ProSoft database, regardless of manufacturer. It also displays the motor torque speed curve, which shows starting torque. Pull-up torque, the minimum torque required to get the motor moving under maximum load. Peak torque, the point at which the motor breaks down and cannot do more work, regardless of speed. And then torque produced under load at slip speed. Just check the box to be able to edit your own and put your own motor and nameplate data in. And then click OK, where we go cancel. Next step is to define the load. Click on the load data pull down menu. This will allow for choosing from several different types of common application which may use a Softstarter. It will automatically create a load torque curve based on a set of default embedded in the software. I will select the pump. If we want to manually edit the load torque curve, then click on the Load Data Edit button. This opens a dialog box to enter data from the load curve. It is necessary to know how much work, how many pound-feet square of force is required at the motor shaft during startup. This is known as a moment of inertia and is measurement of the amount of force required to get the load moving. Also needed is the full rotational speed of the shaft when the motor is under load, known as slip speed. If necessary, it is possible to edit the motor load curve manually by clicking on the Edit button. Here you can enter a specific load torque for every 5% of the motor speed, 20 entries, which will form a linear of non-linear curve. This information should be available from the motor manufacturer or the specifying engineer. I will cancel this and just go with the default centrifugal pump. Just a short recap here. We have the general data, we have the environment data on the top, the general data. We have the motor data. I selected 11 kilowatt motor, ABB motor, and a load data, and I selected a centrifugal pump. So now I will click Next to go to the next tab, that is Calculation tab. So now we have gone through the Input tab. Let us look at the key takeaways. The critical data we need to know is the ambient temperature, altitude, main voltage, and frequency. Also the motor rated power, and last but not least, what type of load our customer application have. But the more detailed information you have from your customer motor and application, the more accurate the selection for our Softstarter will be. Now I have filled in everything under the Input tab. So let us hit Next and get to the Calculation Data tab. Next tab is for Calculation Data. Here we can modify only one of the following data points. Starting time. The time from start until full voltage is reached. Minimum starting time. The shortest time from start until full voltage is reached. Relative starting current for three-phase control. The starting current as a relation to rated current. Absolute starting current for three-phase control. The starting current given in amperes. Relative starting torque. The torque delivered by the motor when started using a direct online, DOL start, expressed as a relation to the rated torque. Absolute starting torque. The starting torque given in a pound-feet squared or Newton meters, depending on units of measure being imperial or metrics. If any field is modified, the other automatically update based on data from the Input tab. The graph displayed here also update to give a pictorial representation of the numeric values. These values show both torque versus speed and current versus speed as a comparison for the various possible motor starting solution: DOL, PSR, PSE, and the PSTX, including inside delta if that option is possible for this application. So that was the Data tab. Let us look at the key takeaways. Higher starting current will give you more torque and shorter starting time. Now we know how to apply the minimum starting current for a customer application and also know the approximate starting time. The motor torque curve for the Softstarter shouldn't at any given time be lower than the load curve. Now we have modified the information under the Calculation tab. Let us hit Next to get to the Result tab. After completing all the fields in the Input and the Calculation tab, ProSoft will show the best option of Softstarter in the Result tab. Check the box if number of starts per hour is important for the customer and if they have a specific requirement, so the software can upsize the current capacity if needed. Then select any of the options listed, which should meet the application specification, assuming the data entered is accurate. That was the Result tab. Let us look at the key takeaways. Select the Softstarter match the customer needs. Number of starts will affect the selection. Now, when we have selected the Softstarter that fits our customer application and needs, the final step is to create a report. Let us look how we do that in ProSoft. Click on the Create Report button in the lower right corner to print documentation supporting this decision. The report generator lists all the options and assumptions made in the data entry, calculation, result, and Softstarter Selection fields of ProSoft. This report is very useful for and should be added to a bid situation, as it shows the customer or specifying engineer exactly how the decision to select the Softstarter model was taken and done, and that our offering meets the requirements given at that time. A short summary. Now we know how to make a selection in ProSoft. select a Softstarter that meets the application. The more information we have regarding a custom application, the more accurate our selection in ProSoft will be, and generate a report that we can send to the customer. Thank you for watching, and I hope you liked this tutorial. Thanks for today, and see you in the next one.